Hello, everyone. I hope we're all recovering well after that questionably hard quiz over the solubility stuff that I know people are confused on. But I hope to try to clear up some of that stuff from the quiz, and hopefully you guys can do well on the test. And of good news that I have, if you don't know already, Mrs. Morales did put on her Weebly the fact that you have the option to retake the quiz and earn a little bit more points back on your actual quiz grade to offset how bad we did on Wednesday. So hopefully after this you can understand it and go back and take that quiz and get some more points, because she even said that most of us were challenged by the quiz, but we all know as soon as Aiden looked back at me and we both just wide-eyed each other, that was just, that was bad. So the things we're going to focus on is double displacement, and then the net ionic equations and precipitate that's formed, and the solubility, and using the solubility chart, blah, 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 blah. All that sweet jazz. So just stick with me. Hopefully this can go decently well, and this clears up some stuff. Jumping straight in to number 18 on your homework, as I'm actually doing it straight from the homework, so this might help you do that. We're going to go ahead and look at this double displacement problem. And the first thing you do in a double displacement is literally just double replace. So you can easily see on this chart, if I get it, that the nitrogen, or not the sodium, will easily overpower that iron. So you can go ahead and just easily just go ahead and switch, even though you shouldn't really put too much thought into that. I wrote those way too close together. So go ahead and write out the double displacement, and then balance the equation. It's not that hard. Make sure, so there's three of these, so you need three of those, and because you have three sodiums, you need three on this side, which means you have three of these, which means you need three of these. Actually, no, sorry. But you don't actually need three of these, because before you do anything, as I'm going to do on the next problem, you need to make sure that these individual new compounds are actually set. So if you look, because each nitrite has a negative charge of 1, and there's 3 of them, which means this fat boy is iron 3, and this little old hydroxide is only has a charge of 1, so you will need 3 of them to satisfy that greedy iron. And it works out because you did put 3 things on there trying to balance out the equation. So now I'm moving on to the next one. Let's just go ahead and freaking switch that boy up, because if you look, our chart doesn't actually have barium, but barium goes right here. He's 3rd, so that's pretty lit. I had to look that up. Barium is way above hydrogen, so it is in fact going to snatch phosphate away from the poor hydrogen. So we'll go ahead and write that out. First thing, as I mistakenly did before that, is what you want to do before moving on to balancing the equation is making sure the compounds are balanced. So as we all know, phosphate is, as you can even tell, hydrogens have a positive charge of 1. And if it takes 3 of them to satisfy the phosphate, that means it has a negative charge of 3. And barium over here, well, he only has a charge of 2. So you have to do the least common multiple, just switch the 2. If there's 3 on that one and 2 on this one, switch them. So you'll need 3 bariums and 2 of these to equalize the charge. Now, lucky for hydrogen and nitrite, they're actually the same. So it's unneeded. They can just chillax. So now that it's balanced, you can finish balancing the equation, which, as we can see, there's 3 hydrogens, which you will need 3 over here. Sorry. But what you do want to look at is the fact that you need 2 of the phosphates. So just go ahead and slap that boy down, which means you need 6 hydrogens, 2 times 3. So put a 6 over here, which means you need 6 of these, and you also need 3 bariums, so it works out if you put 3, because 3 bariums and 3 times 2 is 6, which works out over here. Well, we can quickly move on into the more pressing issue now that we have some double replacement practice. More pressing issue is in fact net ionic equations. Ooh, scary. And they're spectator ions and their precipitate that they form. This is actually a lot simpler than a lot of people thought. Essentially, the whole process is you double displace and then check this chart to see which ones are soluble and which ones are not, or which ones are the exceptions. And if they are an exception, that means they're going to be a solid. They're going to bond together in a nice, happy relationship and sink to the bottom while all the spectator ions stay single and observe it from a distance, because they are infinitely dissolved in that water. Moving on, we can go ahead and look at this, and if you want to double check to make sure that they will in fact switch, hydrogen will easily overpower the silver, because silver is really low. So honestly, just screw that. So go ahead and switch them. Hydrogen 3 and Ag chloride. So these are the two that you come out with. Now make sure they're balanced. Remember that. Ag only has a positive charge of 1 here, and chlorine does as well. If you look on the periodic table, you can see that chlorine has 1. So these guys are actually chill. We made sure everything's balanced. All compounds are balanced. Now we can go looking at this wonderful chart. Now, what this chart says is that if it has the chlorides, sulfates, and all this jazz, that means they're soluble. But if they are bonded with these things, then they're the exception, and it means they're not soluble, which means they turn into solid and sink down to the bottom, happily ever after, blah, blah, blah. The other one is the bottom here, carbonates, phosphates, chromates, sulfides, and hydroxides. Most are insoluble, so it's actually the reverse. So if they do have these, they're going to be pretty much insoluble like 10 out of 10 times. To make it simple, as Mr. Morales said, you don't need to know that for how simple we're going. So, I don't know why I put that away. Looking at this, we do see a nitrite, which, few exceptions. It just flat out says, if it has a nitrite and NO3, it's boned. It doesn't matter. A few exceptions, it doesn't even list the options. So if you see that nitrite, just boom. Even break your pencil, like boom. We don't care about it. But look at that chloride. We have chloride salts here. They're soluble except for these 3 exceptions. Well, look at that. Silver is on there. So that means this guy is going to be a fat solid, which makes him the main product, the precipitate, and that's the answer for the net ionic equation. Literally it. What you're doing is you're doing a double displacement and then figuring out which one matches the chart. So let's go ahead and double displace these boys. I'm going to go ahead and skip why they actually switch, because I bet y'all don't really want to do that. Y'all gotta stop watching this after doing these homework problems and probably go procrastinate, but that's just life. Remember, first thing you want to do is make sure that they're balanced. This guy does need 2 chlorines to satisfy himself. These 2 guys, the lithium and the whatever the heck this is, I forget. Don't question me. They're just chilling because they're both single charges. So we'll go ahead and take a look at this. I actually forget what that is. I forget the exact reason, but it pretty much just completely cancels out because it doesn't really matter, because we already see the chlorine on the chloride and we already start looking for the exceptions. Does this match up with the exception? And it does, which means this boy is in fact a solid. Write the little S, and he's a solid. Boom, that's the answer. You can actually skip all this in your head and just write the answer. That's actually what the answer key has, because screw you knowing how to do it. Let's go ahead and move on to this next one. Real quick, switch these boys. Sodium and chlorine are both single charges, and then we have chromate and phosphate. And if you can tell, phosphate does have a -3 charge, and so does chromate. And chromate has a +3 charge, so they actually chill. Now that everything's balanced, they can just chill. Well, let's look at chloride. Chloride is sodium an exception? And oh no, it's not. And okay, screw it, we don't care. It's not an exception, we don't care about it, we could care less. However, chromate. Here's chromate in number 5, which means most are insoluble. And phosphate is definitely freaking not any metal at all, because both phosphorus and oxygen are nonmetals. So, which means that because it's chromate, that means it's going to be an exception, and mean that most are insoluble, and means it's going to be a solid, and means it's the answer. So it's pretty easy. Now, the specter ions, as I said, were the single boys, the boys that aren't bonded and turn into a solid. So they're in question A, it's the hydrogen and the nitrite. The nitrate, I've been saying it wrong the whole time, whatever. The hydrogen and the nitrate. Those two are the specter ions. Because they're soluble, they're going to keep dissolving in water and never actually combine with each other, so they're going to be separated. That's why they're spectator. They're spectating all the wonderful marriage that silver and chlorine are having. Now we have these two in this one, the two that weren't bonded. I should really look up what the heck this one was. And then we have the sodium and the chloride there. Those boys were the single boys that chilled, and they were the spectator ions. Now, because they are ions, you do need to list the charges of each. If you're confused, you will, excuse me. I mean, it's pretty easy to know the charges of things, but I mean, you should just be able to figure that out. I'm not going to go into detail. This is about solubility as well. Now, number 31, identify the precipitate, which is literally just this, for when the solutions of the ionic compounds are mixed. So, once again, double displace. Do the barium, the sulfate, the hydrogen, and the chlorine. Well, first, and then make sure everything's satisfied. Barium has a charge of 2, and so does sodium. So these two boys are satisfied. These two boys are satisfied because they're both 1. So all is good. So let's go ahead and take a look at this chloride. Well, sadly, hydrogen is not an exception. So we don't care, which pretty much means you to assume, oh, that's an exception. But let's go ahead and look at it. Sulfate, because we have the sulfur there. The exceptions, look, barium is indeed an exception. Great for him. That means they're a happily married couple that gets to make all of these single guys jealous. Moving on to the next one, as I'm just going to go through the entire all the questions to sort of help you guys get the hang of it. Again, the double displacement with this. Now, first things first is you make sure everything's satisfied, okay? If you look at this, you can see that the first of all, sulfates, I believe, are like charged by 2, and that means this aluminum is charged by 3, right? If there's a 2-3 combination, they're pretty much the opposite, the charge. So that aluminum is fat. So we're going to go ahead and because the hydroxide only has a charge of 1, there's going to need to be 3 of those boys to satisfy that aluminum. But lucky for these guys, this guy's a single charge, that guy's a double charge, so there's going to need to be 2 of these. But so that's balanced. Well, let's look at sulfate. Is ammonium on there, that sulfate? No. Ammonium is not an exception, so we could honestly care less. But look at this. That hydroxide right there, remember, hydroxides are most are insoluble, except for select people that we don't care about. It's not that complicated. That means because it's a hydroxide, it means it's going to be an exception. And it means they're going to be happily ever after as a wonderful solid sinking to the bottom. Going to the next one, go ahead and do that double displacement. Now remember what I said about the nitrite, few exceptions. Screw them, we don't care. Which pretty much means that's going to be the answer. But we're going to check. So you don't even have to work it out. And you can look at this and realize that Ag is a charge of 1 and sulfur is a charge of 2. So you can do that to balance it, because you do need to do that. Figure out the charges and balance the compounds. But as we look at this, we have the sulfur there and the sulfate. One of the exceptions is in fact silver right there. So they're going to be a solid. You can write the little s in parentheses that you probably can't see. Moving on to the next one. We're just going to move right along. This is a lot easier than a lot of people thought. I know even I didn't think it was that easy whenever we were taking the quiz, because that was a quiz. So remember, nitrite, already dead before going. And we see the chlorine there, the chloride salts. One of the exceptions is in fact PB. So that means they're going to be a fun couple. But before we write the little solid, we do need to make sure they're balanced. Chlorine is the charge of 1, but Pb has a charge of 2, so there will be need 2 chlorines to satisfy them, and then write the solid symbol, then box your answer. Last one. That way we can then move on, do the double displacement. Look at that. Nitrite. We don't care about them. Nitrites are literally like a death sentence. So we can look at this. And what is that right there? That right there, boys, is a carbonate. And carbonates, most are insoluble, so that calcium is going to just J-chill. They're going to have a nice, fun, wedding. Now we make sure that they're satisfied. As we can see, carbonate has a charge of -2 and calcium has a charge of +2. So it's actually, you don't need to write too much. They're going to satisfy each other and become neutral. So write that solid symbol, and that's your answer. In your head, when you see the nitrite, you can go ahead and just, or nitrate, you can go ahead and just cancel that boy and not care about him at all. So yeah, it's not that hard as what you think it might be. Inevitably, the whole thing is just double displacement and then see if it does form a solid, or if it is, or forms a precipitate, or if it does indeed stay soluble. And whatever doesn't bond is a spectator ion. So, hope this helped. Go definitely take that quiz to allow you guys to get some extra points on that wonderful quiz we had on Wednesday, and get our grades a little bit up before the end of the quarter, and good luck on the tests, I guess. Hope this helped. You can message me for any things if you want me to go into a little bit more detail about things. Bye.